Diagram using the optical pins. A student is investigating the reflection of a light by a plane mirror. Figure 1.1 shows his trace, which is a full size. The trace sheet is there. As you can see, a lamp is placed. You have to just, for these type of questions, you have to follow the instructions to get the answer. So first, the student carry out the initial experiment. He draw the line AB and CD as shown. So what student did, he draw the line AB and he draw the line CD as you can see on the figure. He draw a line AB and CD as it is already shown, and he then draw a line EF. So he draw a line EF at point N, shown on figure 1.1 at an angle theta to the line AB. So we have to measure this angle theta. So how you will measure this angle theta? Using a protractor. You will place, so the line on which we place, that is a reference line. So this will be 0, then 10, 20, 30. So it can be any number depending on your measurement, the scale measurement. For example, this is 10, then 20, and after 20, say it is 23 or 24. So we write that is 23 degrees. The second part, draw a normal. Normal means the line which is perpendicular, 90 degrees. So draw a normal to line AB at point N and extend that normal to CD. And label the point in which the normal crosses line CD with letter L. So what we have to do, this is line C and D, this one is line C to D, and this one is line AB. So we have to draw a normal to line AB, which is at point N, and we have to extend until it reaches line CD. So this is a line AB. Normal is always perpendicular. So we'll place a protractor, mark 90 degree. So we will place a protractor here, the center. This will be, because this is like 0, so this will be 90. And we'll mark a point 90, draw the straight line from AB until it reaches line C and D. And what we have to label, according to question, we have to label that point with a letter L. So this point will be letter L. Labeling is always important. So label the points and use, for these type of questions, use thin lines. So this is a point L, which is on line C and D. The next part, a student places the plane mirror on line E and F. So a student places a plane mirror line E and F and a screen with 2 mm slit on line CD. He then arranged the screen so that the ray of a light shines on a line LN, and then the ray is reflected from the mirror through point P. State and explain whether point P shown on figure 1.1 is suitable distance from N for the investigation. So basically what student did, student placed a slit here, and on line E and F, student places a mirror. So student places a mirror. So what happened when the light from the lamp passes through this slit, strike the mirror, this line will bounce back. And student identifies the position. Student identifies the position of this reflected ray by placing a pin. So the question is it a suitable distance? Basically, whenever we want to locate the position of the reflected ray or the refracted ray, the pin should be far away from the reflecting surface or a refracting surface. What is the reason for that? The reason is because, like example, if this pin is placed closer, there are multiple ways to draw the line. Like example, if this point P is this, as you can see clearly, this point P is very close, but maybe further it is closer. So what happened, because when the point is closer, there are multiple ways to draw the line through that point. So when the point is closer to the reflecting surface, or the pin is closer to the reflecting surface, it won't be accurate. So for the accurate result, whenever we want to locate the position of the refracted or the reflected ray, what we should do, we should place this pin far as possible. So like we should place the pin far as possible. What will the advantage? Because when the distance is more, we can, the possibility of drawing the lines through the point will decrease. So the question is, student places the pin to observe the reflected ray from the lamp. So whether this position P is suitable or not. So what should be your answer? Your answer, it is not suitable. Why it is not suitable? So statement here will say it is not suitable. And why it is not suitable? Because it is closer to the mirror. So when the pins or the points are very close to the mirror, the possible chance of error drawing multiple lines is more, which leads to an error. Or we can draw many lines through that point. Then draw a line joining point N and P and extend until it meets C and D. And label the point at which the line meets C and D with letter G. And we have to measure the distance between L and G. So this was our figure, initial figure. So what they're saying, we have to draw a line which is joining the point N and P, and we have to extend until it meets C and D. So this line, we have to draw another line. In exam, try to use thin lines as possible. So we have to draw a line from N to P, and we have to extend until it meets line C and D. And the point or the position where it meets lines C and D, we label that as G. And the next part, we have to measure the distance between L and G, and we call that as A. So we measure this distance by using a ruler or the scale. We'll measure this. So this distance approximately like 10.2 or 10.3 will be there as you will measure on your paper. Then student repeat the procedure with a value of a theta 25, 20, 15, 10, and 5. So these are the values, and this is the length of A, which is a distance between L and G. So the value of the theta is starting from 25 and ending at 5. And this is a maximum value of a theta. And the minimum is 5. And the maximum value of A is 12.5 and the minimum value is 1.8. The next part, we have to plot a graph. Use the values in the table, plot a graph for A, which is on y-axis, and theta on x-axis. So A is on y-axis. So on y-axis, we have A with the minimum value of A 1.8 and the maximum is 12.2. And for B or for theta, it is minimum value is 5 and the maximum value is 25. It is important that you label the axis correctly, like what quantity you plot on x-axis, we are plotting a theta, and what is the unit degrees. Which quantity we plot on y-axis, according to the question they mentioned A, and what is the unit centimeter. So writing the correct quantities and with their units, that is of 1 mark. Then selecting a scale. So when I select the scale, like if this is 0, 10, so this will be 0, 5, 10, 15, 20, and 25. Try to use more than 70% of your graph paper. Extend the scale as much as you can so that you can use. So 0, 5, 10, 15, 20, and 25. And what about the values of the A? The values of the A, minimum is 1.8 and maximum is 12.2. So we have to select a value of A in which we can include all these values. So if this is say 0, 2, 4, 6, 8, 10, and 12. So it means each box is representing 0.2 because 10 boxes are equal to 2. So one box is equals to 0.2. Now, what are the values we have according to the given table? The first one we have 25 and 12.2. So the first value is 25 and 12.2. So 25 is here. This is 25 and 12. Each box is representing 0.2. So this is 12.2. The second value is 20 and 8.3. So the second value theta is 20 and this one is 8.3. So 8.2, each box is 0.2, then this will be in between. This will be 8.3. The third value is 15 and 5.7 and 10 and 3.6. So 15 and 5.7. So this will be 4.2, 4.4, 6, 8. This will be 5, 5.2, and 5.3. And then 10 is there and 3.7. So this will be 3, 3.2, 4, 6, and in between 6 and 8, there will be 7. And the last one, the last value, five and 1.8. That was 3.6. 10 and 3.6 was there. So 10 and 3.6 will be here, and 5 and 1.8. So this one is 5 each. This one is 1, 1.2, 4, 6, and 8. So these are the points which we have. So 5 and 1.8, 10 and 3.6, 15 and 5.7, 15 and the last value was 5.7. So 15 and 5.7, it should be somewhat. So this will be 5.7 here. Then 8.3 and 12.2. So 8.3 is there, and then the last one is 12.2. So these are the points which we have. Now you have to check according to the points, either the best fit straight line will be there, because what is the possibility when we join, there might be a best fit straight line, well-judged line should be there, because it does not appear that all the points are like, if I want to draw them, a best fit straight line, it won't be, because as you can see, if I try to join best fit straight line, means number of points above and below should be same, but we cannot have a best fit straight line. So we have to identify how we can identify whether we should draw a straight line or it might be a curve. So for this to identify whether you should draw a best fit straight line or you can join a continuous line, a continuous thin line. So simple way is just check the next part. If in the next part they're asking for gradient, find the gradient, then you will draw a best fit straight line. But if they're not asking find the gradient, then what you can do, you can join these points, draw a freehand graph, a continuous straight line. So you can draw a continuous line and joining these points. But don't use thin lines whenever you're drawing a graph. So use always thin lines and don't overwrite on the graph paper. So this will be the line for this graph. How I identify why it should be like a continuous line rather than a best fit straight line. What is the reason for that? Simple way to identify is just check the next step, next part. Because in the next part, they did not ask for gradients. If they did not ask for gradient, then you can draw a continuous line. If they ask for gradient, then what should be the way to draw this? Then we will try to figure out the best fit straight line, which is having maximum number of the points on the line. The line, line does not have to start from origin. The reason is that because we don't know the first point 0, 0 is not there. If it is not there, then we don't have to. If it was there like 0, 0, if there was another where theta is 0, the a is also 0. If that was there, we can start from origin. So depending on the question, suggest a possible source of inaccuracy for these type of experiment in which we are using the optical pin. What are the possible sources of inaccuracy? Maybe because we are measuring the angle theta, so maybe inaccurate. We use thick lines are used, thick pins are used, or parallax error while measuring the angle. So the possible source of error like thick lines, thick pins, thickness of the mirror. These are possible sources of the errors. A student wishes to check his value are for A are reliable. So if you want to explain or check the reliability of the data or the result, suggest how he could improve the experiment using the same apparatus. So what he should do, he should repeat the experiment with the same values for angles. So repeat the experiment with the same values of angle because he did not repeat the experiment. Take an average so he can check the reliability of this result. In question 2, students are investigating how the use of the lid or insulation affects the rate of cooling. Like when we use insulation or a lid, how it can affect the rate of the cooling. Record the room temperature as shown on the thermometer. Use the screen annotation to complete this. What is the room temperature? This value. Use the screen annotation to complete this value. So 23, and the unit is also important. Sometimes they give you the unit, sometimes unit is not given. So you should write 23 degree centigrade. Let's write it is 23. Then 100 cm cube of hot water was poured into a beaker. The initial temperature was recorded in the table. The temperature theta for a time 30, 60, 90, 120, 150 and 180 are shown in the table. This process is repeated for beaker B, like one is with insulation, another one is with lid. Complete the column headings. So what does it mean? Complete the column heading. Column heading means the units what are used here. So what is the unit of a time used? It is second, and unit of the temperature is degree centigrade. Then complete the column for the time. So the first, when we start the experiment, we say time is 0. Use a screen annotation to complete the values for the time here. So this one is 30, that's right, because they mentioned we repeat the experiment 30, then it is 60. Then 120 is there, 150 and 180, that's right. So it means we did this experiment for 3 minutes. One is a beaker with insulation and another one is a beaker with a lid. The next part, write a conclusion stating whether the insulation or a lid is more effective in reducing the rate of cooling in a beaker in this experiment and justify by reference of the result. Like here, with insulation, what is the temperature change when we are using insulation? It is started with 83 and after 3 minutes, it is ending at 68.5. So it will be 83 minus 68.5, which is equals to 14.5. So when we are using the insulation, the temperature change in 3 minutes was 14.5. But when we are using a lid, so it is 86 minus 78.5, which is only 7.5. So which of them is reducing the rate of effective in reducing the rate of cooling, insulation or a lid? So which is more effective, lid or insulation? When there is an insulation, the temperature changes by 14.5 degrees. But when we are using a lid, it is only changing by 7.5. So what it shows that the lid is more effective in reducing the rate of cooling. So here, yeah, that's right. The correct answer is the lid is more effective. And why the lid is more effective? Because it reduces temperature only by 7.5 degrees in 3 minutes compared to the insulation, which reduce the temperature by 14.5 degrees in 3 minutes. So that's how we justify our answer with the reference of the result. One student thinks that experiment does not show effective insulation is on its own and how effective a lid is on its own. Like another student is there because this is performed by a number of students. So one student thinks that this experiment does not show how effective insulation is on its own or how effective lid is on its own. So suggest an additional experiment which could be used to show the effectiveness of the lid or insulation and explain how this additional result could be used. Like, because using this experiment, we are neither able to find the effect of insulation correctly or nor we are able to identify the effect of lid correctly. So what we should do this experiment. So we should do this because for a fair comparison, the parameters should be same. So what we should do, like one experiment we did with insulation, one experiment we did with the lid, and what will be the third experiment? So we should repeat the experiment. With both lid and insulation. So when we repeat the experiment with both lid and insulation, so we can compare like one experiment with insulation, one experiment with lid, another experiment with lid and insulation. So We already performed one experiment with insulation. We perform another experiment by placing a lid, a cap. And the third experiment, what we should perform with both lid and cap to compare the results. So what will be the explanation? So that we can compare the results of experiments. With the previous experiments. You can also do without lid and without insulation as well. This is one way. You can mention repeat experiment with both lid and insulation. That is one way. Or you can also mention repeat experiment without. So you can also mention repeat experiment without lid and insulation. So both answers are correct. Either you repeat the whole experiment with insulation and lid, or you can repeat the experiment without insulation and lid to compare the result, because both ways you can compare and get the answer. So both answers are correct. Then another part, calculate XA. What is XA? XA is the average rate of a cooling of a beaker A over the whole experiment. Use the reading in table. So theta zero means temperature at 0 degree at the time is equals to 0 at the beginning of experiment, and theta 80 means temperature after 180 seconds, and T is the total time, which is 180. So we already calculated this for beaker A. We just calculated the change, but we need a rate of change. So what is theta zero? This is theta zero, means the temperature when we start the experiment, and this is theta 180, temperature after 180 seconds. And so the formula is theta zero minus theta 180 divided by T. So theta zero for beaker A, that is 83 minus 68.5 and divided by 180. So when we divide them, we will get 0.081, and the unit of temperature is degree centigrade and unit of time is second. So it is degree centigrade per second. So here the answer is 0.081 degree centigrade per second. A student in another school are carrying out this experiment using identical apparatus. So another school students are performing the same experiment. State why they should make the initial temperature of a water same as this experiment if they are obtain an average cooling rate. Assume that the room temperature is same in each case. Use the result of beaker A to explain why this factor should be controlled. Like why the initial temperature, like say this is experiment performed in school 1. Another school students are performing the same experiment. So they should keep the initial temperature same. Like example, if initial temperature was 83 in school 1 for a hot water, and they mentioned the surrounding temperature is same, that is 23. Here also surrounding temperature is 23, but the temperature of the water, they should also keep it same. If the temperature is not same, maybe they are taking 86. So this experiment, the comparison will not be correct. Why? So use the results from beaker A, explain why this factor should be controlled. Because the rate of the cooling is also dependent or depends on the initial temperature. Higher initial temperature, faster rate of cooling. So statement that rate of the cooling depends on the initial temperature of the water. An explanation: if we use higher initial temperature, the rate of cooling will the rate of cooling will be faster. So it will cool down in a short time, or a rate of a cooling will increase. That's why, for a fair comparison, the students performing this experiment in school 1 should have the same temperature for the students performing the same experiment in school 2. Question 3, a student is investigating the resistance of a wire. He uses the circuit as shown. Figure 3.1 is the circuit diagram. A crocodile clip is their length. On a figure, draw a voltmeter to measure the voltage across the terminal P and Q. So use screen annotation, draw the voltmeter to measure the voltage across P and Q. How we should connect a voltmeter to measure this voltage? The voltmeter symbol is V with a circle. So what should be the position of the voltmeter to measure the voltage between P and Q? If you connect a voltmeter at like this, it means it will measure only the voltage of P, voltage difference between the point P. We want to measure a voltage between P and Q. So this is point P and this one is Q. So how we should connect? We should connect a voltmeter between P and Q. So this won't be correct. Why it won't be correct? Because this will only measure the voltage across this terminal, not between P and Q. And voltmeter always in parallel. That's why we connect between the 2 points. The next part, readings, and we have to record this readings on the table. The voltage, each value is representing 0.1, so this is 2.6, and here each is representing 0.02, so this is 0.36. So the value of the voltage, that is 2.6 and 0.36. And we have to complete the column heading. So voltage, current is in ampere, 3.6. This one is 2.6 and 0.36. So 2.6 and 0.36. And then resistance is a ratio between voltage and current. So when we divide them, we will get the resistance. So divide these values. 0.36 divided by 2.6. What's the answer for this? So 2.6 divided by 0.36, because that is the resistance of 7.2. Then 2.5 divided by 0.52, that is 4.81. I'm using 3 significant figures. 2.3 divided by 0.71, which is 3.24. And then resistance divided by length. So 90, 60, and 40. So this answer will be divided by 90, because this is R over L. Resistance divided by length. So R divided by L, so 7.22. Resistance divided by length is 90, which is giving us 0.08. Then 4.81 divided by 60, that is giving 0.08. And 3.24 divided by 40, that is also 0.08. So we get the same answer, resistance divided by length, for this column. We did the first two. This part is already done. Then use your results in a table 3.1. Calculate the resistance R25 for 25 centimeter length of a wire. So how we can work out, see, resistance R divided by L is constant. When we did R divided by L, it is always 0.08. So here the R divided by L, what we are getting? We are getting 0.08. So resistance divided by length is 0.08. And now the length is 25. So what is the value of L? L is equal to 25 and this is 0.08. So 25 is divided, other side will be multiplied. So 0.08 multiplied by 25. So we'll get about 2.02 ohm. Because the last column R by L is constant. So R divided by L is always 0.08 according to the table. And if length is 25, so it will be 0.08 multiplied by 25. So we'll get the value for resistance. Suggest one reason why different students carry out the experiment carefully with the same equipment may not be able to get the identical result. So what might happen in the electricity experiment that maybe the wire become hot, or maybe we don't exactly place the marker because we are placing a crocodile clip. So we may not place the crocodile clip correctly, like student may not place the crocodile clips exact positions, or these crocodile clips, their connections are not tight because students are changing the position of the crocodile clip. So when different students want to perform, maybe a slight change in the crocodile clip will change the value for resistance. So position of a crocodile clip or change in the resistance temperature of the wire during the experiment may lead to an error. The student find that the experiment of wire become hot because of high current. She decide to use a variable resistor to prevent the heating, complete the circuit to show a variable resistor. So how we can use a variable resistor? Variable resistor is used to reduce the current. So we connect a variable resistor. Then this wire is there. A resistance wire is there. We can represent by a symbol of resistance. There will be an ammeter and there will be a voltmeter. In place of this resistor wire, you can, in place of fixed resistor, you can also place the resistance wire. So this is how we connect a variable resistor next to a power supply to change the voltage and current in the circuit. So that the resistance wire is already shown. So you just have to complete for a voltmeter. A crocodile clip is there. Connected a crocodile clip. An ammeter is there and the variable resistor. The last question is about the planning of experiment. We have already discussed different experiments.